In this video, we're going to look at finding the area of a semicircle and composite figures. So again, it's going to be half of a circle. A semicircle, to find the area of that semicircle, the area is half of the area of a full circle. So if we think of formula-wise, I want the area divided by 2, which would be pi r squared over 2. Now we don't have to memorize this. What we can do is think about it logically. Find the area of a circle, cut it in half. Half of a circle. So if I look at example A. Here I'm giving a diameter of 6. Because diameter isn't useful for the area formula, which involves r, I want to calculate r on my own. So r is 3. That's the value I'm going to use. So if I were to find the area of this whole circle, pretend the whole circle was in this diagram, that would be pi times 3 squared. And I want half of that. So I'm going to cut that in half by dividing by 2. So the top, pi times 3 squared. So 3 squared is 9. 9 times 3.14 divided by 2. 28.26 in the numerator divided by 2. This gives me an area of a semicircle that is 14.13 meters squared. I'm dealing with area, so I need a square unit. I am not going to add the diameter. That would be if I was finding the perimeter of the shape. I just want the area that it covers, which I've already calculated as half the full circle. B, here I have a semicircle that gives me the radius, so I don't need to do any additional work. Area formula, pi times radius squared. In this case, 11. And I'm going to cut that in half. 11 squared is 121, and 121 times pi is 379.94. I'm going to divide that by 2 to get my area of my semicircle. This gives me a final result of 189.97 centimeters squared. I am not adding anything to that. I've just taken my full circle and cut it in half. Please take a moment, pause the video, and try the try it problem. Looking at our try it problem, I have a diameter of 8. Not super helpful with my area formula, so I need an r value, which is half of it, 4. Area of the full circle would be pi times 4 squared. Divide that in 2 for the area of the semicircle. In the numerator, I get 50.24. That would be 4 times 4, which is 16. 16 times pi. And divide by 2. This gives me a final result of 25.12 meters squared. Now would be a great time, if you have a question on any of those three or that try it problem, to check in. Now we're going to look at composite figures. So these are figures that are built of multiple shapes. We have squares and circles in this example, and half circles in A. To find the area, we have to know a couple distances. So I'm going to give us the first one. I'm going to say the side lengths of these squares are 2. Building this composite figure, I have 4 squares plus 2 half circles. So I have a half circle and I have a half circle. Well, I know a half plus a half is 1 full circle. So I have one circle. Now remember, the squares and the circle have the same, so the radius of the circle is the side of the square. So let's go ahead and build this up. The area of a square is length times width. So 2 times 2, I have a 4, and they're all the same size. So 4, 4, 4, 4. So I have 4 times 4. For the area of the semicircles or the half circles, I could find both areas and add them together. We can see that a half and a half is one full. So I'm just going to treat it as the area of one circle, which is pi times the radius, which we know is the same as the square, 2 squared. So I'm not going to cut that in half because I know that the half and the half make the full, so we're just going to leave it. 4 times 4 is 16. 2 times 2 is 4. 4 times pi is 12.56. Adding all of these areas, the areas of my squares plus the areas of my half circles together, gives me a total area of 28.56 units squared. So we're kind of just building up that composite figure from our parts. All right, let's look at B. I need to know some dimensions, so I'm going to go 3 and 3. Taking a look at the composite, the buildup, I have 2 squares plus this shape. And if I think about what part of a circle this is a quarter. It's a quarter of a circle, or a fourth of a circle. So that means I have 1/4 of a circle. The area of the square, let's do that first. So 3 times 3 is 9, and I have another 9. So that's 2 9s. And then for the circle, I need to find the area of the full circle and multiply it by a fourth. Or I can think of it as divided by 4. So let's do the area of a circle, which would be pi times the radius squared. In this case, the radius is 3. And I'm going to divide that by 4. So I'm going to kind of do that all together. 2 times 9 is 18. And then the value here I get on top, 28.26. Divide that by 4. So that's going to leave me with 18 plus 7.065. For a grand total area of my figure, 25.065. And again, that'll be squared. Why don't we pause the video now and do the try it problem with a dimension of 5 on our squares. So why don't you go ahead and give that a try. Alright, looking at my composite, I'm going to build this up again. I have 2 squares, and I'm going to add, this is a quarter of a circle, and this is a quarter of the same circle. A quarter plus a quarter is a half of the circle it would make. So let's go here. 5 times 5 for the area of the square, 25, 25. So I have 2 25s. Half of a circle would be divided by 2, so I'm going to do pi times the radius, which is 5 squared, and I'm going to divide that by 2. 50. 2 times 25 is 50. And then here, when I do this full calculation, I get 25 times pi, and I'm going to divide that by 2. I get 39.25. for a total of 89.25 units squared. And that is finding the area of a semicircle or a composite figure. So if you have any questions or you had an issue with the try it problem, now would be a good time to check it.